Alright, so suppose we were given the task of defining the addition procedure using just these three procedures here: add 1, sub 1, and 0. At least just using those for the arithmetic section. You can't use plus, minus, multiplication. Alright, so let's define that. Let's say 3 plus 5. What does that equal? But since we can only add things one at a time, we can just we do 3 plus 1 plus 1 plus 1 plus 1 plus 1. So 5 ones is equal to 5. 5 ones added together is equal to 5. So if we do 3 plus 1 5 times, then we're going to get 3 plus 5, which is 8. Alright, so let's define that real quick. Define add. Oh no, let's define plus lambda x and y if 0 y, then we'll return x. Otherwise we're going to add 1 to the plus of x sub 1 of y. Alright, so every time we go through this, we're just adding 1 for every one of these y's, and we're subtracting 1 each time we call plus again. So plus will run y times, and each time plus runs it adds 1 to x until it gets to the end, and then it just returns x. Alright, so let's comment that out and run this to make sure it works. Okay, define plus let's just run it, not define it. Plus 3 and 5. There's 8. Alright, so if you don't understand this, it's like this. It'll come up with something like this: add 1, add 1, add 1, add 1, 3. That's basically what plus will generate, is a bunch of add ones on top of the first number here. So this number of add ones to that. Alright, and it equals 8. Alright, so let's define times. Let's define times, and you'll find this is very similar. So we can use plus now to define times. So what is times? Times 3 times 5 equals 3 plus 3 plus 3 plus 3 plus 3. Well, that's like 3 5 times put together. So let's define times now. Basically the same idea as plus, but it's a little easier to wrap your mind around since alright, so let's take A and B if what have I done? Alright, if 0 B, then 0. Otherwise, let's plus A onto the times of A, and then we'll have to subtract B. Subtract 1 from B every time. Alright, let's run this. So times 3 and 5 should be 15, and it is. Alright, so let's say we want to do an exponent. What is that? 3 raised to the 5th power. And that equals 3 times 3 times 3 times 3 times 3. So that equals 3 multiplied by itself 3 times. So you see here, multiplication was 3 added to itself 5 times for this multiplication, and the exponent of 3 and 5 is 3 multiplied to itself 5 times. So this should be quite easy to make. We can basically just copy and paste this. Alright, except change this to exponent. Let's call it exponent actually, so we don't interfere. Exponent Alright, but of course at the end we don't want to multiply by 0, that would be bad. Multiply it by 1. Right. And let's do the exponent of oh, no. Alright, so up here we did oh, so we got to do the multiplication times of a, which is 3, and this one 3, and then times that times the exponent of a in sub 1 of b again. So it's very similar. So this one called times, it called the plus, and then ran itself again. So just a bunch of pluses, and this one calls the times, and then it runs itself again. Alright, let's see if this works. Okay, so exponent 3 and 5, and I don't know what this should give you. 243, I guess. Alright, now I know 6 and 4 should. Let's do exponent 3 raised to the 2 should be what, 9. Yes, alright, so that works. Alright, so let's come up with a new one. So this was the plus of all the 3's together, this was the times of all the 3's together. Let's call one super and make that the exponent of all the 3's put together. Alright, so I'm not going to write it out mathematically, but let's say lambda a b if 0 b, then we'll return 1. Otherwise we'll do the exponent. Oh, what have I done? Alright, yes, right. The exponent of a times the not the exponent of a raised to the super of a and sub 1 of b. So this is getting sort of abstract here. I mean, what does super really mean? But we're just sort of advancing up. So I mean, this started out with a plus, and now and then went to the multiply. Now we're just going up again, doing exponent on this one. Alright, so this one, the super of 2 and 3, I happen to know is 16 if it works. Yes, 16. But let's say we did like the super of 2 and 4. I bet that's going to be pretty big. Oh yes, see, that's like a very large number. In fact, it's like oh, I think that that's actually supposed to take about like an hour to compute. So I better not do that. Alright. Now that's because at the bottom of everything it's got to do a bunch of add ones and sub ones and whatnot. So let's call one called make one called super duper, which is the super of a bunch of it's like this. Oops, all these 3 strung together but with supers instead of exponents. So let's define this. Define super duper. Super duper lambda a b if 0 a b then 1 else super for a super duper for a sub 1 b. Alright, now we're not even going to run this one, I don't think, because it's just going to take too long. Oh, and we'll hit the run button, but that's about it. Alright, now this will be continued in the next video.